Alright, show me with your thumbs. Is there a GCF?
Yes.
Show me with your thumbs. Thank you, Moses. Yes, there is. Class, tell me, is 3 the greatest common factor?
Yes, sir.
Yes, it is. 3 times what?
3 times 2.
X squared
And then minus x.
minus x
And then
minus 2. Raise your hand if you have that so far. Class, did we factor completely? No. Everyone say inside.
Inside.
Inside now, we're going to use our factoring method called X box. Class, A times C? 1 times negative 2 is? Negative 2. Your B value? Negative 1. 2 numbers that multiply to be negative 2 but add to be negative 1. Negative 2 and 1. Let's write this together now. What do I write? 3 parentheses x. We're going to put negative 2 and what? Plus 1, because it's positive. So in this red box, we factored completely. Raise your hand if you got that. I want to show you, some students don't see the greatest common factor, and I just want to really just really quickly on the side. A times C is negative 18. Your B value is negative 3. 2 numbers that multiply to be 18 are 6 times 3. One of those has to be negative. These 2 add to be negative 3. I could put negative 6x, 3x, 3x squared, negative 6. My greatest common factor going in this direction is 3x. In this case, it will just be an x. Up here would be a, what would I put here? Positive or negative? And over here would be a what? Negative 6. Okay, so then I would have this 3x minus 6, x plus 1. Class, does this look the same? No, but if you cover up this one, what do you have there? You have a greatest common factor, don't you? And you can pull that out. And that's how you get back to the same answer. So if you don't see the greatest common factor, it's fine. You can still do the work here. What's the difference here? The numbers are bigger. In this problem, I had to use the box because my A value is equal to bigger than 1. I used an A value that's bigger than 1. Do you see that? This one, I didn't use the box because I'm looking inside and my A value is 1. Okay? Let's go ahead and graph this. Yesterday we learned now to solve. In order to solve, what do I have to do? Everyone say, set it equal to 0. Let's set it equal to 0. If I solve this, class, can 3 equal 0? Class, can 3 ever equal 0? No solution. You can't graph that. How do you solve for x here? Add 2 to both sides. X is equal to plus 2. Now, where is that on my graph? That is where x is equal to 2. X is equal to what? Negative 1. Now, what does my graph look like? Remember to think of the end behavior when sketching the function. Put your finger somewhere here on a number that'll help you with the end behavior. Show your partner. You should be looking at this number. Now, there's two things. Wait a minute. The end behavior does, if you point it to the 3, that would be correct. Because what it does is it means it doesn't flip the arrows. But the question is, where are my arrows from? Class, this is an even or odd? Evens mean the arrows are where? Same direction. And someone said up. So let's go ahead and make this one up. It is a quadratic, so you have the U. I'm going to sketch my graph. It should go through my x-intercepts. My graph might look something like this. Actually, it goes to a -6. Your C value is the y-intercept, so I should have gone down here. Something like that. Okay? So we factored completely, solved it, and then it helps us draw a sketch.